Okay, so for this worksheet, we are going to be solving quadratic equations using graphs and tables. So the first thing I want to do is use my calculator to find out what all my outputs would be for this equation for these x values. So I go to y equals, enter my 2x squared minus 8x minus 10. Go to my table, and starting at -3, I see my output values are 32, 14, 0, -10, -16, -18, -16, and this is where they're going to start repeating. So then -10, 0, 14, and 32. Okay. So now I want to start finding my values here. So first one is f of x equals -16. So this f of x, if you remember, is another name for y. So this is like saying y equals -16. So if y equals -16, I want to know what my x value is. So when I come over here, I have -16 here. So one of them is going to be 1, and I have a -16 here. So another one is going to be 3. So x is going to be equal to 1 and 3. Okay. So for the second one, this is f of 6. So this 6 is my x. So x is what equals 6. So whenever x is 6, I want to know what my y value is. So when I come over here, I see when x is 6, I have a y value of 14. So this would equal 14. Okay, so for the next one, I have f of -16. And again, this is my x value here that equals -16. So if I have an input value of -16, I want to know what my output value would be for which would be my y. So I don't have that on my table here, so I'm going to have to go back onto the calculator. Or actually, I take that back. I can come right over here to my graph. And what I'm going to do is, oh, I can't do it on my graph. I'm going to have to use it on my table. So I'll just scroll up all the way to -16. And I see that whenever I have an input value of -16, I have an output value of 630. So that's what I'm going to put there. Okay, and then f of x equals 32. So again, this is like saying y equals 32. So if I have an output value of 32, I want to know what my input value is. So I have one input value of -3 and another input value of 7. So that means x equals -3 and 7. Okay. All right. So first I want to use a highlighter or a marker. I'm going to use a marker to graph a line at f of x equals 14. So I want you to, again, think this is y equals 14. And if you remember my, koi Vux thing, that means my equation is going to be horizontal. It's going to have a 0 slope, and I use the equation y equals 14 here. So for y equals 14, I'm going to go right here and draw my horizontal line, and I can see that it's crossing the graph at the points of when x equals -2 and when x equals 6. So that's what I want to use for number 2. So I have -2, so again, -2 and 6, so -2, 14, and 6, 14 would be my points. And the x values are the ones that are always in the front here, -2 and 6. Okay. So now use a different highlighter, or in my case, a marker, for the equation f of x equals -10. So again, this is like y equals -10. So I know again it'll be another horizontal line. So on my graph, right here is where y equals -10. So I see that it crosses at the points whenever x is 0 and when x is 4. So that means I would have 0, negative 10, and 0, 4. So the x values would be 0. I'm sorry. This would be 4, negative 10. So my x values would be 0 and 4. So now I want to find the x values for 2x squared minus 8x minus 10 when it equals 0. So again, this is an output value of 0, so that means y equals 0. So I'm going to use a different color. So y equals 0 on the x-axis here. So I see that it crosses my graph at this point and at this point. So that's going to be negative 1 and at 5. So my points would be negative 1, 0 and 5, 0. And I drew the line on the x-axis. Okay. So now we want to find x values for 2x squared minus 8x minus 10 when it equals negative 18. So this negative 18, again, that's my output value, so that would be y equals negative 18. So my x values for when y equals negative 18, so that's going to be right down here. So it's only crossing it at one point, so that's whenever x equals 2. And so it wants to know what makes this function value different than those in 2, 3, and 4. And it's that this is my vertex, so it's the vertex. So there's only going to be one x value. Okay, so that wants to know how many roots does this quadratic have. So again, the roots are another name for the x-intercepts, and I see that we have 2. And then it wants to know how many are positive. So I have 1 positive. And then how many are negative? I have 1 negative. Okay. Alright, so now on the back side, I have this function x squared plus 6x plus 10, and they've already given me the table and the graph. So now I have to find the values that it's asking for. So it's saying 2 equals x squared plus 6x plus 10. So this 2 is the output. So this is like y equals 2. So it wants to know what x is when y equals 2. So again, I'm just going to go and draw my line here. And I see that it crosses at this point and this point. So those values would be negative 4 and negative 2. Okay. So then they want us to find f of 0. So this is what x equals 0. That's my input. So when x is 0, I see that it's crossing at, or I can actually use my table here. When x is 0, I see that I have an output of 10. Okay. So now I have 1 equals x squared plus 6x plus 10. So again, this 1 is my output. So that's like saying y equals 1. So when I have an output of 1, what is my input, which would be the x? So I would draw my line here. So I only have 1 point, and that would be when x equals negative 3. So for my next one, I have 0 equals x squared plus 6x plus 10. So again, this 0 is my output, so that would be y equals 0. So it wants to know what my input value of x would be to get this output value of 0. So I'm going to go to here. I don't see a 0 here. And then I actually see if I were to draw my equation of y equals 0, that would be on the x-axis. And I can see that my graph does not even touch the x-axis, so that would be none. Okay. So now it wants me to find f of negative 2. So when I have an input value of negative 2, so that would be x equals negative 2. It wants to know what my output would be. So whenever I have an output value of negative 2, I mean an input value of negative 2, I have an output value of 2. Okay, so how many x-intercepts do we have? So we already concluded that we have none. So no x-intercepts. And when we don't have any x-intercepts, that means the function rule cannot be factored. So that's what we want to write here. Function rule cannot be factored. Okay, and that's going to be the case every time that we don't have any x-intercepts. Okay, so now for the next one, 2x squared plus 8x minus 24 is our given function. They've already given us the table and the graph, so now let's find out our values that they're looking for. So here we have g of 2, so that means I have an input value of 2, so that would be x equals 2. So when x equals 2, I have an output value of 0, so this is going to equal 0. Alright, so now I have negative 32 equals my function, so this negative 32 is going to be my output, so that means y equals negative 32. So when y equals negative 32, I see that I have an x value, or input value of negative 2, so x equals negative 2. Right, on the next one we have 0 equals our function, so again this is going to be our output, so y equals 0. So when y equals 0, I have an input value of negative 6, and I also have an input value of 2. So x is going to equal negative 6 and 2. Alright, on the next one they're looking for g of 0. So that's my input value of 0, so x equals 0. So when x equals 0, I see that I have an output of negative 24. Okay, and then negative 36 equals our function, so that negative 36 is our output, so that's y equals negative 36. I see that I don't have that on my table here, so when I come down to the graph and draw y equals negative 36, I can see that my graph never touches this graph, so therefore there would be no solution, so we're just going to put none. And we want to make sure that we don't put 0, because that's like saying x equals 0, and that would not be right. Okay, and on the last one it says how many roots are there? So remember, roots is another name for x-intercepts. So when I look at my graph here, I can see that my graph is crossing the x-axis at 2 points, so that means I have 2 roots. Okay, so last box here. So we have the function x squared plus 5x plus 6, and they've given us the table and the graph. So now we just need to find our values. So I have negative 2 equals our function here, so that negative 2 would be my output, so that's y equals negative 2. So when I have an output value of negative 2, well, I don't see it on here. Let's see. If I were to draw y equals negative 2, I can see that my graph never crosses this graph, so therefore there would be no or none of the x values that would have an output of negative 2. Alright, for the next one we have an output value of 0, so that means y equals 0. So when I come up here, so when y equals 0, I have an input value or x value of negative 3 and negative 2, so x is going to equal negative 2 and negative 3. Okay, so on the next one it says if x equals negative 5, it wants to know what y is. So when x is negative 5, I see that my y value is 6. So y equals 6. Okay, so now we have x equals our function. So this 6 is my output, so that means y equals 6. So when y equals 6, I see I have an x value of negative 5, and I have an x value of 0. So x equals 0 and negative 5. Okay, so now this time we have an output value of 2, so y equals 2. And this time we'll just use our graph. So when y equals 2, I see that my graph crosses at the points of negative 4 and at negative 1. So that means x is going to equal negative 4, negative 1. And the last question is, it wants to know if the roots are both positive or both negative. So recall again that roots is another name for x-intercept. So I'm going to go to my x-axis here, and I see that both of my roots or x-intercepts are negative. So I'm going to circle both negative. And that completes our worksheet on finding solutions when using graphs and tables.